Alright guys, so today we're going to be doing trigonometric or integrals of trigonometric functions. So let's start with uh, products of sines and cosines. Where both will have an, or one of them, actually we just need one of them to have an odd exponent. So let's make this one a square and let's make this one a cube. So the way you address these ones, it's by a little bit of trickery. And it's actually a nice trick. What you will do is you will notice that if you were to make a u equals sine substitution, I mean, when we see products, by the way, let me address this first. When we see products, we tend to think about, oh, well, that's going to be integration by parts. And while that may be true, um, we can fix this, or we can rearrange it to avoid that. So just doing a u substitution. But what happens if I make my u equals sine substitution? I get that this becomes du becomes cosine. And so let me separate a cosine out of here. So we get that. All right, so notice that my du is right here. So I already have that. So what I need to do is figure out, well, and of course, let me do another highlighter here. The u, oh, I didn't change color. Let's change color. Is right. Well, this is going to be a u squared, but think about it that way. All right. So what do I need? Well, that cosine square is causing a little bit of trouble, but I can always rewrite it as sine square of x, and I can write that as 1 minus sine square of x. What am I using there? I'm just using the fact that cosine squared of x plus sine square of x, that's ugly x, is equal to 1. So I subtract the sine on both sides, and I get that the cosine, or the sine squared rather, I get that the cosine squared is going to be 1 minus sine squared. And with that, then I can do my substitution quite conveniently, where my sines are here, and my cosine dx is going to be my du. So I can write that substitution in, and I get u squared 1 minus u squared, and then du. And at this point, it's just a matter of distributing. When I distribute my u squared, I get u squared minus u fourth du. And then you know how to do this. You do plus 1 u cubed over 3 minus plus 1 5 plus c. And then we just take back our substitution where we get sine plus c. And that's my integral right there. All right, so let's look at this one right here. Sine to the fifth, cosine to the fourth dx. And so you again are going to try to look at the function that it does not the power of 5, that is not the power of 5, or odd power rather. So my substitution would hopefully be u equals cosine x, and my du would become negative sine x dx. So based on that, so I grabbed the one that is odd power, and I would also choose the one that is to the lowest degree. So if, for example, I had a cosine cubed, I would choose the cosine, or if I had a cosine to the seventh, I would choose the sine. So I'll choose the odd one with the lower degree because then it makes it a little bit easier. All right, so let's take a look at this here. So I'm going to have that this is going to be the well, I'm gonna separate a sine because you see I have a sine here. So I'm gonna do sine x. Let me put the sine at the end. I'm gonna separate that sine as, actually I was gonna write sine anyways. Sine to the fourth, cosine to the fourth. And then I'm gonna write that sine x out here, dx. Why? Just preference. That's just because I want. And multiplication is commutative. And my cosine does. Sorry, I lost track of what I was doing for 1 second. Just because I should have modified this a second ago and make it a negative du. It's gonna be sine x dx. That now I can actually grab that. That's the one I wanted, and I'm gonna make it equal to this one. So I'm gonna have a negative du coming out of that. That's the only thing I was griping with myself about. And now here, let me change it to yellow. I have now this right here would be my u to the fourth. So you see I have a sine to an even power. So how do I address it? Well, I want to turn it into a sine squared somehow, because the sine squared I can substitute with 1 minus cosine squared. So the way to do it, remember, when you have the power of a power, the exponents multiply, so 2 times 2 is 4. So I'm just going to write that as sine squared squared. Cosine to the fourth, I have no problem. That's just going to be a u to the fourth. That's dealt with. And this sine is going to be a negative, or sine x dx rather, will be a negative du. So I'm already reorganizing things. I'm gonna go ahead and rewrite this one as 1 minus cosine squared of x, the whole thing squared, and then cosine to the fourth, and then sine. All right, and now it's just a matter of writing my substitution. So the highlighter back, u equals cosine, cosine, so I get 1 minus u squared, u to the fourth, the whole thing squared, and then here, this one's gonna give me a negative du. All right, so let's put it in. So I get negative, and then I'm going to put the du at the very end. 1 minus u squared, squared, u to the fourth, and then du. And I took care of this negative out here. So now it's just a matter of foiling that square. It's kind of annoying, but it's probably the easiest way to go about it. So let's go ahead and foil that. So negative, I get 1 minus 2u squared plus u to the fourth. Just the square of the first, the double product, and then the square of the second, times u to the fourth du. And now I distribute, and I'm going to have negative the integral of u to the fourth, put a parenthesis here to include everything with the du, minus 2 u to the sixth. Plus u to the fourth, remember, 8, sorry, the exponents add when you're multiplying, and then du. And at this point, we get negative u to the fifth over 5, plus, I'm distributing that negative, remember, 2 u to the seventh over 7, and minus, because I have to distribute that negative, u to the ninth over 9, plus c. And then we just substitute in the cosine, and that would complete the problem. I kind of don't have much room, so I'm not gonna do that. But that's how you address these kinds of problems. One more, just to make sure, it's gonna be a little bit different because I am not gonna have sines and cosines. I'm just gonna have one of them. So what about now, which is sine to the fifth and no cosine there to be seen? Well, it doesn't really matter because you can think that cosine is to the power of 0. That's an even power. So when you have an even and an odd, you do the same thing. In fact, odd and odd doesn't really matter. Just think about cosine being there to the power of 0. So we're going to think, well, this is the odd power. Remember, we picked the one with the odd power and the lesser of the two, if there's one. And in this case, start with odd is 5. That's going to be the one we pick. And we're going to make that... we're going to make our substitution will still be u equals cosine x. You're like, wait a second, you said that that I didn't have any cosine. Yeah, it cosine to the 0. Just think about it that way, and you'll see that it will work out just fine. Now your du would still be negative sine x dx. Okay? All right, so with that in mind, then we will try to separate a sine out of there. So we're going to have sine to the 4th, and now you're going to start seeing how it's going to work out just fine. And then sine x dx. Okay, so my highlighters, and you'll see that one will be missing. I have my negative, oh, I forgot to write it again. So negative du is your sine x dx. So now you can write your substitution is going to be this right here, which is going to give me a negative du. And you say, well, but now I have no cosines, but that's the same thing we had before. This is going to be a sine squared squared, and then that sine squared I'm going to replace with 1 over cosine squared, 1 minus cosine squared rather. And I saying cosine made me write cosine. And this cosine will appear in my integral the way I needed it. So it's going to be 1 minus cosine squared x squared times the sine x dx. And now let's go to the highlighters. Now I do have a blue. You see cosine wasn't there, but now it is. I can substitute it in there. And my, different color. My sine x dx is going to be my negative du. So I'm able to plug it in. So I'm going to have negative for the du. And there's going to be 1 minus u squared du. So just a matter, again, of foiling this out. Negative the integral of 1 minus 2 u squared plus u to the 4th du. So this is just what we had before. So I'm going to integrate the 1, it's going to give me a u, multiply the negative, so negative u. Integrate the 2 u squared and multiply times the negative, so it's going to become plus 2 u cubed over 3. And then minus u to the 5th over 5 plus c. And it's just a matter of substituting in your sine and you're done. Alright, that should take care of whenever you have an odd power of sine or cosine around.